screen. We're going to need to move that. I wonder if we ought to do that now.
We're recording right now, though, right?
Yeah, that's fine. I'm just, because we're going to get to the point where...
It won't show that screen.
Yeah, it won't show that screen. So I don't know how we're going to do this. Can you see can you see me up there?
Yeah, if you look.
Let me move this and see what we can come up with. That's okay if you're recording. We can edit this stuff out later.
Ben comes over to you. I don't know. Where do you want me? I guess you're probably okay there.
Okay, that's too high, right? I want to be able to see that wall. So if we decide to not...
You set it on top of that computer? Monitor that is?
Yeah, we can take this and... I don't know, will it clip?
That's a good question.
No. Let's just set the box here. Let's move it up a little bit. It's just an empty box that we set up there. I'll get a lot of it.
Yeah, we kind of do a sharp angle.
We might need to move it back to get more. Oh, that gets it.
Probably drop it down. Yep.
That'll work. We'll see. And if we have to re-record, we'll re-record later. Okay. Like I said, I think ultimately I want to maybe hook something up here that we drop down. Well, let's get started. I don't know who we're missing, Hanif, but okay. So we're going to sit at monitors today because we're going to hopefully by the end of class we'll get you logged in. We'll have an exercise that should be on your desktop. You confirm they're all there, right? That the doc was on the desktop for each of their logins? Okay. So we'll get you started on an assignment. Good? Okay. John's somewhere in, I don't know, Delta, Fillmore, somewhere in central Utah doing some work. Okay, could you bring up the PowerPoint then that I had there? Or I guess I can do it too. Yeah, that's the one. Oh, did I just mess it up? Okay. There we go. Okay. So I'm going to finish up. I got 3 things I want to accomplish today. 1, I want to go through, finish off this seismic stuff. 2, I want to talk about a syllabus or a prospectus, because I had that in our syllabus to do last week. We didn't get there. And 3, to get you logged on to the workstations. Those are my 3 goals today. We'll see if we can power through and get there. So to finish up the seismic, the rest of this is mainly just some examples of how we use seismic on projects. So I already showed you. I remember I said that it's got a smiley up there. It's one I showed you on the first day of class. I just had pulled slides from different decks. So, but this is an outcrop. Anybody who knows where 9 Mile Canyon is? Oh, it's called the world's longest art gallery. It's out near Price, Utah, south of the Uinta Basin. And there's an amazing amount of Native American art, pictographs, and petroglyphs along this canyon. And you can just drive for miles and miles and miles and see tons and tons and tons of it. But anyway, there's a formation out there called the Green River. It's the one that has oil shale in it. But if you zoom up, you kind of got these interbedded layers of sand and shale and sand and shale and carbonates. And I just had shown this before to give you a sense of what you might be resolving with a wavelet. And if you look at it at log scale, you have rocks out here, sands. Remember, this is sampled on 6-foot intervals. And we can really zoom up in here on these individual sands. And I think I showed this as well. And what we resolve really depends on the frequency content. So this should have a little more meaning than it did the first day. After our discussions of last week about frequency and phase and polarity, that what I do in terms of frequency and phase here, I can resolve thinner or thicker beds, depending on what we're looking at. So, again, just driving home the point, well log resolution versus seismic. They are different. Oh, that was just a cool picture. Never mind. Okay. And I think I showed you this one. This is up in Green River Basin North in Wyoming, western Wyoming. It's called the Birch Creek Field area. And so, see faults. I think I showed you there's a thrust fault right there. There's a big one back here. And we want to figure out where the hydrocarbons are. It turns out there's a big field right here, and these faults play a big role in segmenting the field. So is it important to know where the faults are? There we go. Okay. It is. Why? Why do you want to know where the faults are? What does it affect?
Migration.
Migration? What else? Huh? It's got to affect other things. What else does it affect? The engineers ought to know this one.
Faulting.
Yeah, what does the faulting affect? If you're producing hydrocarbons, what might the faults affect?
It is seismic potential.
Seismic, I don't know what that means.
Earthquake potential.
Oh, there's a potential? Yeah. What else might it affect? If I were to frack it and pump a bunch of fluids into those faults, I could reactivate them, right?
There's a seam that will allow like piping the fluids.
Yeah, it could be a thief. In other words, it could capture fluids and cause them to flow into other reservoirs. It could be the inverse of that, right? It could be a flow barrier. So if I put a well into one fault block and I start producing oil out of it, doesn't mean the oil is going to come from across the fault into the next reservoir and producing. So you might need more wells in between each of the fault for each fault block, because each one might need to be produced separately. So fluid flow, that's why I said the engineers ought to know this. Barrier to fluid flow. Yeah, I'm picking on these guys. So my geology should know though too. How do faults affect hydrocarbons? And they do. Because migration is a typical one, because you can cause faults can capture migration and move them to other reservoirs. So those are both. We can process the data, and so I'm looking at a bird's eye view down into the earth, about a second down in offshore New Zealand, a place called the Taranaki Basin. And so we've processed this. It's basically something known as edge detection. They call this semblance, and all we're trying to do is measure how similar traces are from next to next. So if I've got a fault, the traces are going to be different across the fault. Because if I've got layers like this and I move them down, right across here, they're going to be different. The geology is going to be different on either side of the fault. So we can pick up boundary conditions in the processing of the seismic data. Pretty simple to do. Data sets are using this class, we could do it in about 2 minutes. We can come up with different attributes. And so this particular attribute is trying to highlight edges in the response of your reflections. And so what are these things here for my geologists? What does that look like? Channel. Very good. Say it really loud, May. We're friends in here. You can yell at us. Okay? Yeah, channel systems, right? And what kind of a channel system is this one right here? It's a meander, yeah. So I got a meander system coming through here. Okay? This is almost like a braided stream out here, right? So what do you think these things are? You think that's a channel or something else? It's a fault. Yeah. And we see in faults, we often use the term en echelon, where you have a fault and then it steps over. If I were to take something and just crumple it like this, you can see a series of en echelon faults. We use the term relay ramps. You know how you can walk across the fault system by walking around? Who's seen a relay ramp? Who's heard of a relay ramp? Okay, very good. You're from Indonesia. You probably got to see a few of these in Indonesia. Or with Ron Harris. Yeah. Have you been to Capitol Reef? Yeah, there's a number of relay ramps in Capitol Reef National Park. You can actually walk across them. So basically, you get across the whole fault zone without actually ever stepping on the fault. Because you got to break here, and then the stress steps it over. Metal responds the same way. You can have these in echelon. Depends on the stress direction. And we're, sigma 1 and sigma 2. So anyway, we're seeing a series of faults there. These dark things in here happen to be volcanic intrusions. It's magma that came up, never quite made it to the surface. And then you can see the faults related to those that broke in. But another company actually shot this 3D survey looking for oil. Yeah, they're using, because there's oil in this basin. And there's oil produced on the side of another volcano offshore.
Is this seismic data taking a slice of it from a bird's view?
Yep.
So it's not like an aerial picture of the ground surface.
No, it's like this. And I took a slice out from like that. So you can start at the top, and I can animate down through the data volume. We'll do that with some data you're going to see today. Okay? So we'll just work our way right down through the data volume. So, like I said, the cool thing about three-dimensional seismic data is that you can look at it from just about any angle. You can rotate this plane this way. You can do it like that. You can run through the data. I can look at it this way, however you want. And that's the cool part about technology and the software. This is where the video games come into play. The technology that we had for that. When we first started interpreting 3D seismic data, they would actually print these out on Mylar, sheet of clear plastic, put it on a light table. Have you guys used a light table? See, there's a few kicking around the department still. Light shines up through the bottom. You put a piece of clear paper, or semi-clear paper over the top, and you would trace where you saw something at, say, 1,000 milliseconds. Then you'd put on the next piece of Mylar that would say 1,050 milliseconds, and you would trace what you saw there. And you would make a map. By hand, using a light table and sheets of that. That's how the first 3D interpretation was actually done. It was originally done on time slices and not on vertical sections. Interesting approach to it. I've done it I'm old enough to have played with that kind of stuff. So this is a view down. So other ways you can display the data is to use a histogram to peel away and display only the positive values. And only the positive values that have a certain dynamic range. In this case, we were able to highlight in Old Delta, this happens to be a 2 billion barrel oil field offshore Brazil. We can look at our data as an amplitude, as the same data set. Exactly same data, just had a filter ran over it, processed it slightly different. Do you see something more in here that you don't see there? What do you see here? I do take response. Okay, so what do you see? Come up here, draw for me. Come on up. I made you speak up.
Some channels here.
See, show me the channels.
This is it.
Yeah. It's all right. Go ahead. You're good.
Across.
Yeah, or maybe it's a little bit older. Yeah.
Yeah.
Yeah. Very good. Yeah, that's good. You see that channel meandering through there? This here is probably the outline of the basin. It's kind of sagging in. And this channel system was running out here across at the time. So we can see that kind of stuff. Now, again, remember that first picture I showed you of Halo? And you saw that wall with all the bumps on it, kind of? That exact technology using that video game was what created this picture. It's called bump technology. You take one data set and map another one on top of it to create a texture. So when you're playing the video game, you don't want to redraw all the triangles every time as you're running down. You just change the wallpaper as you're running by. So instead of bricks, it becomes rocks. Instead of rocks, it becomes, I don't know, paneling or something without really changing anything. And so what we've done here is we took this data set, took this one and mapped it as wallpaper on top of the first data set. Now it's even more clear, isn't it? So anyway, think about how technology drives. And it's going to change for you guys. Okay, I'm still here. Okay. This right here is a salt body. And here is a fault, basically, and another one there. And I'm just drawing an arrow to show which way this block has moved down. So as the salt's pushing this block up, it gets kind of rafted. And it moves, and this stuff, and this salt, go back, okay. This salt used to actually extend out further. But because of sedimentation, it's been squished, right? It gets pushed down, and then the sediment flows up, or the salt flows up. So now I've created a hole over here, and I've created a bump over here.
You see the weld right there? You can see the weld on the side.
Right in here? Come up here and show me what you're talking about.
No, I'm curious if you can.
Yes, you can. Yeah, he used the term salt well. What's a salt well, Jeff, now that you've thrown it out for us?
Well, I guess so, yeah. So if you deposit layers, you deposit on top of the salt, and it gets squished out where the sediment meet. That's where the weld is.
Yeah, exactly. So think of a toothpaste tube that's full of toothpaste, and you step on it, and when the two outside edges of the toothpaste tube come together, that's the equivalent of a salt well. Weld, W-E-L-D. So I basically forced all the salt out, and I've taken two different age of rocks, and I've just smashed them one on top of the other by squeezing out the creamy stuff. So where's that happening? Now, that's a great question. It's in this one, there's one right here. If you envision that this salt actually used to go up there, and those rocks here used to be up there. And you can see that because you can see that this rock there is the same as that one. And so if I were to do a reconstruction, I would push that up. And when I move it up, I've all of a sudden got space down here. And so we talk about things called like a space problem. How did I fill the void? What was in the void? What was there? How did it get out? And so we created a void in some way or another. And when this vacated due to stepping on the toothpaste tube, equivalent thereof, salt migrated up, this comes down and creates a salt well. Cool, huh? Okay, so get rid of all my scratchings here. So this is just a little video clip. Oh, come on. There we go. What I want you to watch is how does the salt body change shape. And there's my interpretation of the existing salt. And you can see the base of the salt layer moving away from us now. So that's not some spherical cow. That's the real world of what that geology body looks like. that salt body. If this was a reservoir, we'd call this the container, right? We'd want to be able to do something with that. We'd want to know the shape, size of that. And that's what we're going to do later in the class. And we would want to quantify the properties inside that container. Oh, another pretty picture. Okay. Again, this is the same data set that we've been looking at. It's just a different way to look at it. And so what we do is we take, there we go. If this is a histogram of, getting the drama. If this is a distribution of the amplitudes in the full data set, I could draw a filter on it and say, take all of this out and only display the samples under the curve. And when you do that, you get that. We've just said take out some of them. And we display these. So this is that volcanic, or this is not volcanic, this is the salt body over here. And this is really cool because here you can see, that's a bad color. Let's go to a different color. How about blue? Is that one easier? Can you see these channels coming through there? Can you see one coming down here? And then this is a big delta. Probably another channel coming across there to another little delta under there. So it's a different way of displaying the exact same data, but using the computer imagery to get your mind. Remember I talked about getting your imagination focused? Very beginning, I'm trying to focus your imagination right here. Okay. Nankai Trough off the coast of Japan. This is kind of cool. So right here, this is the subducting plate that's going underneath. So this is a compression zone. This is where two continental plates are colliding, coming along, and one's diving under the other. And so right here in the middle of this, you get this really chewed up stuff that's caught in the mixer. As the sediments come over and as this goes under, it just gets churned, right? Geologists, what do we call that? Huh?
Accretionary wedge.
Yeah, an accretionary wedge. Very good. Melange zone, something that's all mashed up. But it's the accretionary stuff that's get caught in the middle. Okay, and if you look really close up here, can you see that guy? That's an old back arc volcano that's been buried. Okay, so we go on. We can actually map that seafloor. That's one way to look at it. Another way to look at it is as this volume render. A really cool way to see what's happening. And what's this right here? That's the subducting plate. That's the plate diving underneath. Be headed off to get melted, right? It's going to head up down here, and it's going to do what? It's going to melt, right? And it's going to perk up, form a volcano as it comes out back behind the subduction zone, which is what we see happening where today in the U.S. I'm kind of bringing this home here. I know where it is in Indonesia. You know where it is in Indonesia, right?
Where's their subduction zone?
Yeah, where's their subduction zone with volcanoes?
Right off the coast, the west coast, right?
The West Coast, yeah. Is it in L.A.?
More north.
It's more north. Yeah, Northern California, Mount Lassen, Mount Shasta, St. Helens, Rainier. Those are all these volcanoes that are formed basically in this environment. Okay? But we can use technology to see what's going on. Wrong way. And then that's the seafloor out here. And so there's one of those volcanoes. This is from Costa Rica. This is very similar to what we would see. And there's a whole string of volcanoes in Costa Rica because it's an active subduction zone where this is occurring today. So other ways that we're going to do it, and we'll spend more time doing this. I'm probably going to, in terms of projects, remember I said we're going to have one project for the whole class. But now that I've got 6 students instead of 3, I'm probably going to break into 2 groups of 3. We'll have one work on John's ADM project, which is the CO2 sequestration project. And the other project I'm going to have you work is this one from the Uinta Basin. Because I've got 3D seismic and I've got well log data. So, and I already showed this slide, it looks like. But this is all shale right here. And on the well log, it's that to there. And so this green is all a hot gamma ray, which shows where the shale is. And these blue guys are where there are sands. And so these become your reservoir rocks, those guys right there, or potential reservoir rocks. So again, this is the type of interpretation that we'll have you do. Make a couple maps, pick the well logs, correlate. You can see, so log correlation, John probably didn't cover log correlation, did he? So, but in log correlation, if I've got a sand, would you guys believe me if I were to say that this, and this sand are all the same sand? That's correlation, right? I'm matching patterns from one set of logs to the next. Okay? And this top right here is probably the same geologic age formation. And if I really get into it, you could probably see that there's a little blip right there that looks a lot like that blip, which looks a lot like that blip. And we could correlate those. So that's log correlations. That's what we're going to do next. We'll get and learn how to use the software. Then we're going to come back and we'll do a little bit of seismic interpretation. And then we'll have you put that together in a model. Okay? So I already showed you these slides. This one I put because I had an imagery of the surface and then the subsurface. And here's a fault zone right there. That well, interestingly, hit right in the middle of the fault zone. Had no production out of it. Right? I just, by circumstance, happened to get it. And as we zoom up, we can get even more detail of where the sands and the shales are. So the other thing we can do is use seismic attributes. And what's a seismic attribute? We really haven't talked yet about that. We'll see if we get into it in this class. We may or may not. But an attribute is I want to say a subset of the waveform that we've either calculated or extracted from the data set. So just like on the well logs, and I said, these might be where sands are, right? On the seismic data, we can do the same things because there's a unique pattern here. So if I have a waveform coming down, I could extract some set of properties associated with that particular part of the waveform and then try and look at it in a 3-dimensional sense and say, does it make any geologic sense? Does that pattern help me see what's going on spatially? Because I don't have enough well logs. Remember, I've got seismic everywhere and I got well logs vertically. 2 different densities in different directions. So on this particular one, this particular attribute shows that there is a stream channel here. And this is probably, if you're familiar with deltas, a splay. Think Mississippi River. And when the water goes over the bank carrying sediment during flood time, it carries all those sediments out and then drops all the sediments in just some spot. Those are splays. Okay. This is from Oklahoma, Arkoma Basin. What's a karst for my geologist?
Is it carbonate?
It's a carbonate rock, yep. And what's happened to the carbonate?
Yeah.
Chemically dissolved? Yeah, so we talk about sinkholes. You get karstic topography. You could actually have a layer here of carbonate, another layer of other sediments atop it. And if the water, the hydrologic features coming through here erodes this away, you can actually have this create a hole and this collapse into it. In the event that all this is away, we can still karst it. So Florida today is largely karsted terrain. There's some great ones in southern China that I've always wanted to go visit. Amazing karsted topography. You probably have some in Indonesia as well.
But not as big as the China.
No, not as big as the China ones. I gave a group of 15 folks from China a tour from here to Denver on geology once, and they were from the region where all that karsted topography. They were the geologists that worked that, and I thought, oh, I'm envious. I want to go see this. So anyway, here's some karsted topography, and how are we going to know it? We're going to do a little attribute, and this shows us where all the karsted topography is. And these guys are what? I'm looking kind of bird's view down. I'm looking at the surface. Not a channel. If I were to tip it on its end, it would look like this. They're faults. But these are where the sinkholes are, so to speak. Why do we care where the sinkholes are? Porosity can check to your fluid flow. Or even more importantly than porosity, permeability. We want to know both. We can have tons of porosity and no perm. So we want to think about that. The reason these guys were actually, this was a company. One of our students actually worked it as his master's thesis, and then he went to work for the company. They had found that a certain formation that everyone thought was not, basically they were a basin like this, and everyone thought that this formation had eroded out and was gone. And there's a zero line, on the surface like this. And it was all over here, there was none over here because it was all eroded away. They found some out here in a couple of wells. And they started scratching their heads, how did we get this formation way over here? And we don't see it in very many wells. We can drill a well a mile away and it's not there. But in this well it is. And it turns out that these holes had formed when that formation was still there on top of it, and it had fallen in to the karsted topography, and then it got buried by other sediments. So there were these islands of a formation that was generally productive. And they wanted to know where they were. So, seismic. So here we're looking, this little blip turns out to be a channel system that you can map out. And we could even label it geologically with different types of features of the deposition. Think offshore or southern Louisiana, like in the Mississippi Delta, and you'll see things that look just like this. Here's another way to look at it. Oh, I got to show you this, and then we'll get done with these. Okay, keep your eyes open. This is water depth right there in feet. Or is it in meters? I think it's in feet. What is that? It's a whale. 3,000 feet below, and it's checking out the wellhead. This is a wellhead, and they had a semi-submersible down there, and there's a guy in it. They're checking out the equipment. Pretty cool, huh?
Is there a guy in it?
Yeah, I think so.
That's how that camera reacted to the whale.
Yeah. Did you see it jerk? Yeah! Yeah, exactly. Anyway. So I thought that was pretty good. Okay. I'm going to stop on seismic there. Those last two slides, I just wanted you to get a sense particularly since none of you have had seismic interpretation, at least here, I know Hanif's had it before, of what you can do with it and how we use it. So we gave you last week the whys and wherefores of the wavelets and the phase and the frequency. This was just meant to give you a quick flavor. Discard the annotations. We'll get rid of that. And I'm going to minimize that. Oops, I don't need that. So I want to shift gears. Okay, syllabus. Oh, well, this is not the syllabus. That's to be the spreadsheet. Someone asked about grades, but we'll give you a grade on the prospectus that you write. Big bulk would come from just being here in class and doing all the exercises, and we'll start giving you real exercises to do, and then your final presentation. So the prospectus was part of that grade. And in our schedule, we talked about, maybe I can make that a little easier. Is that easier to read? Okay. So we are really right here this week. That's where we are. Just kind of orient us back to where we were going. Now, we had talked about doing a literature overview. John was going to do that. John's not here. So I'm going to still push you guys a little bit. I want you to start thinking about what a syllabus might look like, and I wanted to just show you one. Huh? Yeah, what did I say? Prospectus, yes, thank you. So this is just a simple one that someone had written a couple of years ago. Maybe this is our prospectus for the class. We asked the class to work on that project from Wyoming called Birch Creek. And we asked them to go do a little bit of research to find out what they know and what they don't know about the field and the area. Okay? And so this is 6 pages here with graphics. Okay? It's not all that long. You don't need that page. I'm not sure why that's in here. That's just the class schedule. And this was a figure they pulled out of the literature. So you can see that it wasn't all that long. I'm not looking for a tome, you know. What I am asking you to do is to do a little bit of homework to make sure you understand, you know, what we're going to go after. You know, this is a graduate level course. You should know. You guys are undergrads, right?
I'm graduate.
Huh?
I'm a graduate student.
Okay. So do you have to do a prospectus? Okay. And you guys have had to do one yet? Have you done them already? By the end of this semester. But you've done yours.
I've written it, but I haven't.
Okay. You've done it. Okay. May's there. Okay. So you've all done one. Okay. This, except for Alex, maybe. So you're going to rely on your classmates. And so, as I said a few minutes ago, I want to break into 2 groups for this project. And so I don't know if you guys want me to assign or you want to self-divide if you want to work. Any thoughts? This is a discussion.
You should just assign them, I think.
We go with people who are interested in working in Uinta or Illinois.
Yeah, okay. Let me ask this then. Who's interested in working the Illinois CO2 project?
What's the other?
Huh?
What's the other project?
Well, I'll come to that. I'm just asking who's interested in working CO2. It's a model on CO2 sequestration. The other one is going to be in the Uinta Basin. And that'll be that one I just showed you where I zoomed up on the well logs and the sands and the Manco Shale. So any interests there? Any preferences for working one or the other?
I'd rather work the Uinta.
You'd rather work the Uinta.
Yeah, I don't do it as well.
You'd probably rather work Uinta as well. You'd probably get brownie points working CO2 for John. He's your advisor, right?
Yeah.
Huh?
Yeah. All the brownie points I can get.
There you go. Do you have a preference? CO2. Do you have a preference?
I don't have a clear
Okay.
idea.
Of what they are yet, right?
Yeah. Both are using the same software.
Same software.
Doing the same interpretations.
Uh-huh. We'll do seismic interpretation, and we'll do well log analysis and geostats, and build a reservoir model as your project.
Both of them have 3D.
They both have 3D. So they both have 3D, they both have well logs.
I just never all like
Okay, you two want to do Uinta, and you two want to do CO2. And who else wanted to do Uinta? You did. So we'll make you CO2. Does that work, Alex? Yeah. Okay. So with that in mind, I'm going to give you the assignment for the next week. So let's look at maybe a week from Thursday to go and look at some literature. We'll try and get John back in. Is it time to go? Okay. Someone's got to keep me in line because I don't. Go ahead and get started. And so where am I looking at in Uinta Basin? For those doing Uinta Basin. Who's doing Uinta Basin? Remind me again. Okay. So Uinta Basin. Think it's not just Uinta Basin because there's a lot of fields in the Uinta Basin. This is called North Hill Creek. Okay? Let me write that down. There are several papers that have been written out here. It's also called Flat Rock Mesa. I'm just giving you some search terms. Wind River Resources has done a lot of the work out there. I'm trying to think. I'll come back Thursday with some more field names in the area. Okay? And so the formations of interest will be the Entrada and the Dakota. Trying to think what else. The Wingate and the Mesa Verde. Those are all the formations that are of interest. Okay? So that should work. That'll get you started. I'll bring some more. I've got a paper that I've written on this area that I'm happy to share with you.
So we're researching these areas of these formations with the goal of building a subsurface model of this area,
Yep.
including these formations.
Yeah. And what is the hydrocarbon potential?
So one thing that helped us also that you mentioned last year was kind of give a big picture understanding of the basin, right? And then kind of go down specifically what are your goals.
Yeah.
So like a basin overview, and then the petroleum system overview, et cetera.
Yeah, exactly. Great example. And so in the paper, in the final paper, that's what we're going to want. And so in this one here, they talked about what they were going to use, but they also talked about, what are the main formations here. I got you engineers split up, right? So you got two geologists and one engineer. That probably works for you guys. They're trying to get a sense of what is the rock formations that we're going to be looking at. I'm going to try and dig out a talk that an alumnus of ours by the name of Brent Greenhalgh, his brother Scott finished a thesis here a couple years ago. Brent works in Salt Lake for Questar, or Wexpro, or whatever they call it nowadays, getting merged with Dominion as their lead geologist, geoscientist guy. And so Brent, he comes in and he shows a Blakey diagram for those that don't, those that know what one is, that don't. It's basically what does it look like the plate tectonics perspective in the time frame of the reservoir being formed. There's a guy named Blakey, right? Who has built a whole series from like 1 billion years ago to today with snapshots through of what we think different parts of the earth look like. So he started at that level, his talk. I just asked him, I didn't tell him what to do. He just came and started, I'm going to start with this giant big picture. And he started working his way down to the prospect level. And that's a pretty good, I've got a doc posted to contents. Can you bring that up? Can you bring up my browser? Or maybe I can do it. Heck, I can do it. I think I can do this. There we go. Oh, it's going to make me... Well, here's a thing called Play-Based Exploration Guide. That's a good doc to go look at. That'll give you a perspective of what we're going to try and accomplish. That was written for people that participate in what they call the Imperial Barrel Award. But it's still a good document. Gives you a good outline. Can you open that at all? Can you get there? Yeah. Might have to go to student view. Just click, yeah, go ahead. Look at that, he signed in on me. Okay. So, yeah, I can go from here. So he talks about this thing called the pyramid. And the pyramid is basically, here's the basin focus, here's the play focus, and there's the prospect. We're going to start this big, and we're going to work our way up to what we know about the data. Okay? And so it's a good, quick overview if you want to go read that. I should give you some guidelines. And so I'm just looking for a prospectus. I just want to know that you've done a little bit of reading about what's going on in this area geologically so that you have a sense of how to get started. We'll give you the technology. You don't need to do research on that, okay? But I want you to understand the science and what are the problems. You're in a basin, they're basically going after a gas play. Okay? There is oil in the shallower and there's gas in the deeper. And you might say, well, why? Talk a little bit about that. On the ADM project, they're not really going after hydrocarbons. They're trying to figure out, is this formation a good reservoir to pump CO2 into? So it's the inverse problem. Is there enough porosity and permeability in the sandstone that I can shove fluids into it? Now, look, I'm sure I can get fluids out. But it's still a reservoir problem. It doesn't matter.
What's the seal problem and the trap problem?
It's a seal and a trap. I pump them in there. Is there a good enough seal to make sure they don't come up? And the other one I'm trying to figure out, is there enough seal that they haven't leaked out? So same problem, same issues. And so, anyway, that's what we're after. Okay, is that helpful? So,
Mine from last year, would that be helpful if I sent
yeah, absolutely. That'd be wonderful. And you can email through Learning Suite, I think, to all the students. Great. So he'll send you one from last year. That'd be good. So we'll just break you up into those two groups. I think that'll work for us. That way we get two different projects. You're not following all of each other. With 60, it's almost too many people, particularly to work that ADM site because it's a really small 3D survey. I mean, you can map all the horizons out in about an hour, if that. So this other one, the geology isn't, the structure is not very complex. So, which is good because I haven't spent a whole semester teaching you how to interpret seismic. So I'm going to try and, the data sets we're giving you are pretty simple in terms of structure. But you will need to make a top and a base of the key horizons. And there's log data for both of them. So we'll play with the logs. Okay, any questions on that? So get reading, and I'd say by Tuesday, give me an idea of what literature you found. So I'll give you a week to go chase literature. And then we'll decide if maybe by Thursday to have your prospectus written. If you think you need more time, I'm negotiable. This is a graduate course, right? We can have some give and take here. But that's where I'm driving towards. I don't want you to wait. I want you to get started. So certainly bring a literature list by Tuesday of next week. And at least be prepared to talk a little bit with the class about what you found. Okay? and we'll just have a discussion in class. I think that'll work. So we'll spend part of the class period. We won't spend the whole class period. We'll spend part of it on that. Okay, good. Okay, perspectives. Man, I got 2 objectives done. I am making progress. Okay, so our next thing to do is to get you on the workstations. So, can you take that and just, undo the blank and log in? You know the password, right? Whichever, you want to use the 12? Why don't you? Go ahead. I'm going to erase this. Is this okay? Okay. Now, before he gets fully engaged up there, man, how'd you get that? I put a username over here for each of you. You see it? Find your username. That'll be the one we'll use most of the semester.
Do you want to see it on the projector?
Huh?
If it's projected, can you see it on both screens? I'm not seeing it in the current.
Seeing what? The login?
That screen on the monitor. Is that
You should be able to see it.
should be okay? I didn't know. Yeah, because we were seeing it earlier.
Yeah.
I don't know why.
You're not, that's the only, it's the other half. Yowzer.
Oh, is it on here maybe?
No.
It should be over here. Okay.
Now, why did this slip on us?
You knew something. You knew something was gonna happen.
Yeah, I mean, we practiced this before class. Okay, Jeff, I'll have to just point to you. Okay, so when you guys log in, turn on your monitors, make sure your computer's up. My goal is to make sure you're in.
I'm not seeing my login.
Okay, so if your login's not up on the list, hit Other and type in your username. So Alex here is
Geol.
9. So type in GOP9, no spaces. Hit Return, log in. Your password is landmark, all lowercase. I've written it right up there. Looks like the other Alex figured it out. So, yeah, turn on both screens. You guys will have 2. We're going to be working with 1. Okay, so you're there, May's there, Hanif is there. Yeah, and turn on both monitors, so we'll use them both. That's weird why this one didn't come on. Password is landmark. There you go. That makes it easy for them to see with the white. So, anybody not there yet? Okay, where's your other monitor? Raleigh?
Just turn on. Probably it's on.
Okay.
There's no input signal.
Okay, we'll work with 1 for the moment. We'll figure that out probably later. I want to make sure you got logged in. Okay, so most of you got it. And if for some reason your workstation. Yeah, he can't. Oh, he can't see the other half. Is it plugged? Is it? Yeah, it's in. And it's in down here. It's all screwed in.
Just log out real quick. Just come to over here by Handy real quick.
Go sit on that one. Why don't you move over here, Ben, and see if you can be okay on this one. I mean, we can try and chase it, but I just want to make sure you get there.
Log out of Linux.
How do you log out of Linux? Yeah, Just go over to the other one. Yeah, you should. It's probably on the other screen. Yeah, he can't see that. I'll figure it out later. You can still log in on another machine. So you log in to work on any machine in the room. From day to day, you can come and set up machine A, and then next day come work at machine B. It doesn't matter. We've got all of our data and our software hosted on the machine in the back. Your logins are hosted out of there, so it doesn't matter. Right, yeah, this will work. Yes, right here. This is fine. Okay. So we wanted to be able to get in. There should be a document on your desktop. These are Linux, not Windows. And where's your doc that you got on here? Yep, that's it right there. So what here it says BYU DSD docs. And if you double click on that folder, go ahead.
Oh, good.
You get a folder that pops up. And the document I want you to open is called Getting Started. Okay, so I'm just making sure that I'm here, that you're with us before I move on. Okay. So there are a whole series of instructions right here that will walk you through step by step. There's some things of just getting into the software. I'm going to walk you through how much time. Again, I'll check that with about 20 minutes. Okay, or 15 minutes, I guess. So we'll walk through part of this right now to get you started. But I'm going to leave it to you to finish this chapter out by class on Thursday. Okay? So we probably won't finish it, but we're going to get you into it and just show you some stuff. Okay, so scroll up through here a little bit. I'm not going to, you guys can come back and read it all later. We're going to go to right here where it says applications. And what I want you to do is, double click on, back up so they know what you did. Slow down. Should have an icon that says landmark R5000.8. Do you find it? Anybody not find it? Double click on it. It should put a little launcher. There, you got yours. He's got his. You don't need to resize it. It's got everything there. You've got yours. Got yours? Yours? You guys good? Okay, I'll stand back here. Okay, we're going to launch the application by finding the word applications at the top. And then first item on your list is decision space geosciences. Click on that. You should get a splash screen up. And we're going to follow along with you guys here. Just wait. Okay, and you see he's got this little message that it says it's working. Okay. Now, on this list, there's a couple of tabs about, right up there at the top. Existing sessions, new session. Why don't you click on new? Okay. So what we're doing here now is there's a set of applications, different types of tasks that you can do using this software. We don't necessarily need to launch all of the functionality of the application. So we're going to just choose a couple right now. I think the application has you open 3 of them. It has you click on GIS, if you're following the instructions, it has you click on GIS. And if you hold down your control key, you can select others, well log correlation, and seismic interpretation. Okay? Yeah, we'll just follow the instructions. So we're going to choose those 3. So they're highlighted. Now, as soon as you click those, something pops up down here. Okay? And this is where, I'm afraid to erase this because I haven't written it down anywhere. Sure. Well, yeah, you can take a picture. Go ahead. That'll work. I can write it down here at the bottom. Let me write this. So May is 6. Ben is 7. Hanif is 8. We have the two Alex. Alex B is 9. Alex W is 10. And Raleigh is 11. Okay, that's good. So I'm just going to erase this now. Be a little cleaner to see. Okay, there we go. Okay, so we want you to choose here a project. One is called an OpenWorks project. We're going to choose something called DSD Norway. DSD Norway. You click, this is the second item down. Click on the down arrow. You get a whole list of projects you can choose from. Did you find it? Okay, you found it? Did you guys get it? Anybody not get it? Okay, we're good. Okay.
So don't trick, there's another one that just says Norway. DSD.
DSD, yeah. DSD Norway. This one's built to follow this manual for the most part. Okay? So the next thing we have to choose, says interpretation project. Next arrow, just choose all data. So we're just going to work our way down this list right now. That's all we're doing. So we chose the project, OpenWorks project. Now we're going to choose interpretation. We say just take all the data. Okay, what is our measurement system? This project here is in the North Sea, off the coast of Norway. So our project's going to be in what units probably? Metric. So there's something called SPE, preferred metric. We're going to choose that one. Now we can choose to display our data in time, like seismic data, or in depth. We're going to choose time to get started. Interpreter. Now this isn't, for right now we're going to use one identifier for all of you. But we're going to click this first one, the OISTA. And then, let's see, I don't know that we're really going to leave the rest. We're not going to mess with the rest, at least right now. Okay? Anybody not completed this? Okay, you're good. Okay, you're going to come down here and say, okay, lower right-hand corner. And you'll get a new splash screen coming up. Okay, so it doesn't have the GIS on here right now, it looks like, so don't worry about it. Registering engine binaries might take a little while. We don't have any initial exercises in GIS anyway, so I'm not going to worry about that. You can close that. Okay, that's good. So now, if you were following along in the instructions, you've got this desktop. Is really what it is. And it's got, if you were following along in the manual, it would tell you certain things about this desktop that we're looking at. So this section here is a panel or a window. This is a tab. So this is going to display a certain type of data called a section. It could be seismic data, it could be well logs. This is a cube view. This one here is a map view. Okay? We're going to bring some data in here to display to get started. Okay? Column over here is your inventory for the most part. There's some other things that can be in this column. It's very adaptable. You can change this and put it however you like, and over time, as you become experienced, you may move them around. These are where you're going to choose certain activities, like seismic interpretation, well log interpretation, geostatistics, making the reservoir model, building frameworks. We'll choose some of those parameters over here. But this is where we're going to, for the most part, keep track of what we have displayed here. Okay? So,
If you don't see it, you have to make sure to put the inventory tab. There are different tabs along here.
yeah. And so whatever's highlighted in red is the one that's actually being displayed. If we were to click on inventory there at the top, we see there's nothing displayed in here right now. And that looks like that, right? Looks like the data is empty. So we got to go get some data. So we have all of our data stored in a project or in a piece of software they call OpenWorks. It's just a relational database. If you've not done databases before, it just allows you to say, put all the well logs here and all the seismic here and all the horizons there. And whenever you need it, it just goes and finds a pointer to go get it. So it makes it a fairly easy way for you to find your data. Rather than having to go what they call flat files, rather than finding the .doc file or the .png file or the .jpeg or the .whatever, the data stored in the database, rather than being stored as a bunch of individual files. So we'll use that. Okay. Over here on the right, across the top, they often refer to that as the heads-up display. It kind of has a bunch of the fundamentals. We'll talk about that in a few minutes. Anything I've left out, Jeff, I should talk about?
I don't think so.
Okay. Under interpretation sets, or I sets, they call it in the documentation. It's a way to say, God, I've been working, whenever I come into this project, I'm always going to work with 2D seismic, 3D seismic, and a certain set of wells. And you can, the exercise at the end of this chapter is to build your own I set. Okay, so we're going to use some existing ones right now to bring some data in. If you don't have an I set, you can still bring in data individually, one chunk at a time, and then save it as an I set. That'll be your exercise. So we're just going to choose an I set right now. So I want you to choose geophysics. It's right on that bar there, but let's just do that one first. Yeah, you got it. Very good. And there's an up arrow right here for uploading, load data to session. So we're going to click on that. You know what?
Oh, yeah, I have that. I missed something.
You're in horizon interpretation.
It's over on the left side.
Yours is under tools. Oh, yeah. Okay, someone's moving around. There you go. Choose geophysics, and there's an up arrow. Find the one. No, up here. Right up. Go up. Yeah. Go up. Right there. Just see the float over. It says load data. Just click on that. Okay. Okay. Looks like it looks like you're there. And you're there too. She's got a different size box than you do. It's okay. You probably remember from somebody here last time. We'll play with this.
Yeah. So one thing I guess you can talk about was the zoom in and out speed.
Yeah, we haven't done that yet. We'll get there. I just wanted them to get open first. Okay. So now over in your inventory, if you look at my inventory, you can, if it's over here, where's your inventory button? There it is. So click on your inventory. So you'll now see that under inventory, remember it was empty before? Someone created this I set, and there's all kinds of stuff in here. And so there's 3D up there, there's 2D data, there's faults, there's wells, there's horizons, there's log curves, there's a whole boatload of data that was brought in that we can come and manipulate. And so you look at that and you go, wait a minute, this doesn't look quite like what's in my book yet. Okay? That's okay, because we haven't turned on the data. So right now, if he clicks in map, I want you to notice that tab becomes active. If he clicks over here inside a cube, that window is active. So we can bring data from inventory and drop it into here if we want. So one way to do it is we want to turn on 2D lines. Can you see 2D lines there? There you go. These arrows, these little circles over here, if they're green, it means the data's on. And if they're gray, it means the data's off. So he just turned on, and it shows where the 2D data. So those are just the line locations in a 3D sense. Now, we can play with that vertical scale. It's called Z factor. You can see it up there at the top. It says 5 right now. Okay? Yeah, I don't think you have the box. Might not be turned on. So we can play with the parameters for this, right? Go ahead. I just want to get a cube. Some people have big cubes. You don't have any cube in there. Go to arrow. Okay. Oh, let me make another point. The cursor has multiple modes and functionality. Right now you see a hand with an arrow on it. A hand is really for manipulating. So if he drags that around, notice how he can rotate and spin that. If he wants to select an object, he changes it from hand mode to arrow mode. And you can do that by clicking here or dragging your data kind of out of the data area and just double click with your left mouse button and you can toggle it. There are some mouse pads laying around that have some of these shortcuts and hotkeys for the decision space. You've got one, you've got one. That's for the geoprobe. Here's another one for decision space. Looks like we're missing one more. There should be plenty of these. Here, I'll put it between you. You guys can argue. Okay? So a lot of those shortcut keys are going to be on here and things that you may or may not want to do down the road. So you're going to follow. I'm not necessarily following this in the exact order that it was in here. I'll let you do that. But I just want to show you some things that we can do. We can put some 3D data in here. So we can come over to 3D data. Let's do that full offset. Now you're going to right click on that for a minute. And there's an option that says load to shared memory. I'm going to have him do that. I want you to do that. So if I'm moving too fast, raise your hand, tell me to stop, wait, because I don't want to move until everybody's with me. So we find the 3D volume, we're going to right click. Right there, right click on where it says full offset and say load to shared memory. There you go. Okay, you're there, you guys there? And you're there? Okay, good. We're going to go ahead and just take the full volume and we're going to, now, why do you choose? Because it's going to put the data into the RAM on your desktop. And if you've got, 20 gigs of data, you've only got 5 gigs of RAM, you want to be able to subset it. We don't have to do that here. This is going to take 0.44. And these machines have about 64 gigs of RAM. So we should be okay. This is small data set. Go ahead and hit OK. And you'll see a progress bar coming across here. So this one says available RAM and how much is required. And this has got some stuff's been left over from other people's work sessions. Okay. Now we can close that. Good. Now we take the one we've loaded, the shared memory. It'll have a little cube. You just drag and drop it in there. And we're going to choose box. Hit OK. Okay. Now, I may want to see this in a bigger view. If I double click on the tab, I can fill the window. Okay?
You can stretch it into your segments.
Yeah, you can drag your window across if you want.
This one or this one?
Yeah. Whichever one is, I can't see. Yeah, that one. You want to drag that one over. Yeah, and choose right down there. Hit OK, box. There you go. So you've got right now this little teeny box. This little teeny box, which is not the full data volume. It's what we call a probe. So we're going to make this probe bigger to see more of the data. So I'm going to ask Jeff to put that in arrow mode right here. I ask him to grab these are handles, the squares, and just drag it. It's not a very big data set. It's a really small one. Now he can drag this scene around. Left mouse button rotates it. Middle mouse button drags it. And if he wants to zoom in, he can roll the wheel on his mouse to zoom in. And you'll say, that seems really slow, the response to the zoom. If you want to speed up the zoom, just bring your cursor up to this little icon up here at the top, the compass. Right-click on it and say Zoom Sensitivity. And right now it's set for really low. See, it moves much faster.
Do you remember the hotkey to out center? The control.
It's not P. I think it should be on your pad. Is it L? Okay, Q view. Move, rotate. Yeah, that's it. Oh, just put the cursor on top of it and hit M. There you go. Makes that the
So if you ever
same.
get like false view or anything,
Yeah. So did you get a probe or a line?
I got a line.
So you didn't load the shared memory one. Come down
yeah, I
there.
did that one.
Yeah, do
This
the other
one?
one. Yeah.
Drag that in?
Yeah, drag that one in. And then choose box.
Box. Okay.
And then go OK. Or apply. That'll work too.
Okay, and then with this slice.
That's just an inline or cross line. We'll go over that a little later. So, within a shared memory, the way they've written the application, the shared memory allows you to slice and dice the cube in a lot of ways. If you don't put it in shared memory first, it just asks you, do you want to bring in a line, or a cross line, or a slice? But you don't get the volumetric part of it. It just pulls an individual line out. That's all it does. Okay? So that's why we had you load into shared memory first. So now we're looking at seismic. I got 4 minutes left. One last thing before we get out of here. If you want to animate through the data, make sure you're in arrow mode. Put your cursor on the face that you want to animate. Hold down your shift key and just hold down the left mouse button and it will drag around.
It's a small data set.
It is a very small data set. And you notice in this one he can animate from any side, including the top. And there's some pretty cool stuff in here. So I'm going to make one last little pitch. Is it 350? Oh, I was watching time up there. It's at 342. So it's time to go. Okay. I want you to spend a little bit of time just looking at the data. The first step in interpretation is just look at the data. Bring whatever geologic knowledge you have to the table. Try and say, what am I seeing? What am I observing? Okay? We'll keep going on Thursday. Okay? So go through the exercise in that chapter, that document that you just opened today. That's your assignment to do before class on Thursday. Okay? Any doubt what the exercise is? What are you supposed to do? Go through that document, that PDF I had you open, and go through all the steps. Okay? That's your assignment. This is where we really start getting your grades. Okay. Yeah, I guess my clock's off on that computer. Oh, now how do you get out? How do you get out? We ought to have you exit. Yeah.
So yeah, that top bar on the left side says system.
Yeah, but let's not. First, get out. How do we get out of the application? You can go to File, up in the upper left-hand corner. No, that wasn't File. File, and say Exit. And if you say exit, it usually asks, are you sure? It gives you that, I call those the hey stupid question. You know, hey stupid, do you really want to do this? Are you sure? And if you say yes, it will exit that. Then to log out of the computer itself, we're up here. You're going to find the word system right up there. And you're going to drop down and it says log out. And you can log out. And that will take your computer back. And if you leave it sit there idle for a certain amount of time, it will lock the screen anyway. And you'd have to type in your password.
Sometimes we found that some people just switch user instead, and then they switch a few times, and it won't let them log in because they're logged in as too many.
Yeah. Well, there's too many licenses checked out.
Okay, that's it.
So if, say Alex here comes in and logs on this one, does his work for a day, but he doesn't actually log out, he just leaves it up. The application's still running. And then when he comes back to class, he doesn't remember which machine he used, so he goes to the one over here. And he logs in as Alex again. It checks out another license. Now imagine each of you doing that 2 or 3 times. And then Hanif comes into this machine and he can still log in as him. There's just another login that's not being active right now on here. And he checks out a license. We have a limit on the number of licenses. And we've seen where people have just left a ton of stuff running and we get in trouble. Okay? Good. Well, thanks for sticking around for a couple minutes. Well, oh no, you're there. I was going to say, you didn't leave. I was just looking for you there.
Yeah.
You were over there. Never mind. Well, thanks for sticking around.
Yeah.
Can you terminate the window with this one?
That's terminal window. Not terminate. Yeah. So that, if you click on terminal window, go ahead and click on it just so you see what you get. It's just a window you can type commands into. It's a command window. Okay. See. Okay. So put your cursor on the top. Just go into arrow mode. Now put your cursor on the face. Hold down Shift key. Now push down the left mouse button.
What?
The left mouse button. Hold it down.
Okay.
Yeah, there you go. And you can do that on any face. You could have also brought it up and down by just grabbing the handle on the side of that.
Yeah, I did that. But it can go.
I was just going to rotate it up a little bit. It just depends what part of the cube that handle thinks you're grabbing. Okay?
So no need to hold this here.
If you just grab the handle, no.
Okay.
But it's an easy one to just put it on the face anywhere. You don't have to be as precise. Okay, your question.
Should I remove these folders?
Yes, go ahead and remove them from shared memory. Just say yes.
And then log out from.
And then to log this out, you go to where it says system, and go down to log out. And it says, are you sure? Yeah. Log out. Okay? You're welcome.
So it turns out if we log in with the administration,
It works.
One, it works on both screens. You can see it all.
But the other one doesn't.
No.
So we use the admin from here on.
Yeah.
I'm not even going to try and work on it. Okay.
Oh shoot.
Is that me? Yeah, I can get in there. I'll fix it. We're good.
You mind logging in so I can shut the feed?
Oh, sure. We got too much going here. There you go.
Should I say no?